To the economist in the house. In our last video, we did the output maximization, we derived it. So today we are going to be using these values to actually follow the steps of that derivation we did, and then we'll now get, because the question says we should show that the firm maximizes output. Solution. One good thing about this is that if you are able to do the derivation, then solving this won't be a problem. But trust me, there are many ways this can be solved, and I'm going to be pointing them out one after the other. Is that okay? So the first thing is, let's make this 100 minus 2L minus 4K, and then we introduce the Lagrangian multiplier, which is Z equals to 5L raised to the power of 3, 0.3, and K raised to the power of 0.7. Then remember I told you that minus a clause, so let's just then minus your lambda into bracket 100 minus 2L minus 4K. So let's open this. We have 5 L raised to the power 0.3, K raised to the power 0.7 minus 100 lambda. This times this, and this times this, you have minus 2L lambda. This times this plus 2L lambda, then plus 4K lambda. Right? So it is at this point now we have to differentiate our z with respect to L and K. Right? We differentiate the z with respect to L and K. And when that is done, let's start with L first. So you're going to have your 5 multiply your 0.3, then L raised to the power 0.3 minus 1. Then you have your K raised to the power 0.7. This is 0. This is 2L. So we have plus 2 lambda equals 0. All right. Now this, if you multiply this, you are going to have 1.5 L raised to the power 0.3 minus 1, K raised to the power 0.7. This goes, it becomes equal to minus 2 lambda. Now, this, you can decide to simplify it, that is 0.3 minus 1, which will give you minus 0.7. Or, just the way you did the derivation, you can expand this to be 1.5 L raised to the power 0.3 multiplied by your L raised to the power minus 1. Then you have K 0.7 equal to minus 2 lambda. Now, this can be done where this becomes 1.5 L raised to the power 0.3 multiplied by 1 over your L, then K 0.7 equals to minus 2 lambda. All right. So this also can further be broken down as 1.5 L raised to the power 0.3, K raised to the power 0.7 divided by your L equals to minus 2 lambda. So you can refer to this as equation 3. 1, 2, 3. This is equation 1. This is equation 2. All right. So now that we've gotten that, let's now differentiate with respect to K. So we're going to differentiate our z with respect to K. We'll have 5 into bracket 0.7 L raised to the power 0.3, K raised to the power 0.7 minus 1. Then we have plus 4K lambda equals to 0. Now, always equal to 0. So this becomes, if you multiply these two, you have a 3.5 L raised to the power 0.3, K raised to the power 0.7 minus 1 equal to minus, this is the K is out, sorry, 4 lambda equals 0. So you have minus 4 lambda, the 0 is off. All right. Now, just the way I simplify this, we're also going to simplify this. It's 3.5 L raised to the power 0.3, K raised to the power 0.7 times K raised to the power 0 minus 1 minus 4 lambda. And then finally, this becomes 3.5 L raised to the power 0.3, K raised to the power 0.7 divided by your K, because this is 1 over K equals to minus 4 lambda. This is equation 4. So now we are going to divide equation 3 by 4. 1.5 L 0.3 K 0.7 all over L, then divided by 3.5 L 0.3 K 0.7 all over K equal to minus 2 lambda all over minus 4 lambda. This minus cancel, lambda cancel. 2 here is 1, 2 here is 2. All right, so meaning at this right hand side, we have 1 over 2, right? So we have to simplify this side as 1.5 L raised to power 0.3 K raised to power 0.7 all over L, then divided by 3.5 L raised to power 0.3 K raised to power 0.7 all over K equals to 1 over 2. We are able to simplify, we don't have a problem. So we simplify this, that will give us 1.5 L raised by 0.3 K raised by 0.7 all over L times K all over 3.5 L raised by 0.3 K raised by 0.7 equals to 1 over 2. Now you realize that this will cancel out this. Okay, so what do we have left? We have 1.5 multiplied by your K all over 3.5 multiplied by your L equal to 1 over 2. Now I want you to note something, right? We need to convert this to a fraction, convert this to fraction, and at the same time we'll simplify. So let's expand this. We have 1.5 over 3.5 times K over L equals to 1 over 2. Now 1.5, note that 1.5 to convert it to fraction is the same thing as 15 over 10. And 15 over 10, 5 can go here 3, 5 can go here 2. So which means here is 3 over 2. Then this division sign, 3 over 2 is 1.5. Then this division sign is what we have here. Then 3.5 is the same as 35 over 10, right? 5 can go here, you have 7. 5 can go here, you have 2. So 3.5 will be 7 over 2, then times K over L equals to 1 over 2. All right. Now, 7 over 2 can be simplified as 3 over 2 divided by 7 over 2, then times K over L equals to 1 over 2. All right. We simplify this. We have a 3 over 2 times 2 over 7 times K over L equals to 1 over 2. These two we cancel. So we have 3 over 7 times K over L equals to 1 over 2. Now there's something very critical we need to look for here, because we are looking for this 2 and then we have this coefficient attached to it. So what do? We'll have to divide this by 7 over 3 over 7. We also divide this by 3 over 7 so that K over L will be standing on its own. So we'll say divide both sides by 3 over 7. So we have 3 over 7 all over 3 over 7. Remember, we have our times K over L equals to 1 over 2 divided by 3 over 7. So this we cancel this. We are left with now K over L equals to simplify this, we have 1 over 2 divided by 3 over 7. So our K over L will be equals to 1 over 2 times 7 over 3. All right. So K over L will now be equal to 7 over 6. Now it was at this point we got to during our derivation. So if you have not watched the derivation, you can now go back to my previous video to look at what we did. Now, what are we going to do? We can decide to look for K, or we can make K subject here. To make K subject, we multiply both sides by our L. So we have L, K over L equals to 7 over 6 L. So this L will cancel. Is that okay? So if that L cancels, we are going to have K to be equal to 7 over 6 L. Now this is our K. We'll now come back to this. Come back to this and substitute this value of K here. So we say substitute, let's say equation 4, let's say equation 5. So we say substitute equation 5 into equation 2. So what do? We say 100 equals to 2L plus 4 into bracket 7 over 6L. All right, so that is what you're going to get. We can simplify this to be, excuse me, 100 equals 2L plus 4 times 7. That will give you 28. So we have 28L over 6. This is over 1. We can now look for the LCM, right? This is 100. The LCM will be 6. 1 into 6 is 6 times this. You have 12L plus 28L. All right. So if you add these two, this is 30, 40L. 100 equal to 40L over 6. So at this point we cross multiply. So you are going to have this times this. You have 6 times 100 equals to 40L. All right. So if you multiply these two, you have 600 equals to 40L. Now this can be written as a 40L equals to 600. It's the same thing, just to rewrite. All right. Now at this point, we can now divide both sides by 40. What are we going to get? We have a 40L over 40 equals to 600 over 40. This will cancel. Then our L will be equal to this will cancel. How many times can 4 go into 60? I think that will be 15. So our L is equal to 15. Now that we've gotten 15, we now substitute this L into equation 5. So substitute L equals 15 into equation 5. All right. So we now have K equals to 7 over 6 times 15 because our L is now 15. So let's quickly do that. 1, 5, 7 is 35. 5, 3 is 7. So we have 1. K will be equal to 105 divided by 6. If you divide 105 by 6, our K will be equal to 17.5. Our K is 17.5 and our, what is it called? Our L is 15. So the question is, what are you going to do? Because the question says, show that the firm maximizes output. So since we've gotten our K and our L, we are now going to substitute our K and our L into the output here. So we'll now say our output therefore will be equal to 5 into bracket 15 raised to the power of 0.3 times 17.5 raised to the power of 0.7. Now, 15 raised to the power of 0.3. 15 raised to the power of 0.3, you have 5 into bracket 2.253, kind of. Then times 17.5 raised to the power of 0.7. So just think that will give you around 7.415. Then if you multiply these two, you multiply everything you have here, then your output is going to be, now listen, 5 times this, whatever answer you get, multiply it also by this. Is that okay? You can make use of your, in fact, at this point, your calculator should be your friend. Okay? So here, approximately, you're going to have 83.546. So depending on whatever your calculator gives you, at least you will be within this range. All right. So it is at this point that the firm maximizes output when it chooses labor as 15 and capital as 17.5. Is that okay? Bye.